To draw a box plot, the command is box plot, and we'll need to give it a numerical variable. So I'll use the chicken weights, chickwoods, $ weight, control enter. The box plot shows the median, which is this thick line here. The edges of the box represent the 75th percentile and the 25th percentile. 75% of the data is below this line. 25% of the data is below this line. The height of the box, so this dimension here, is the interquartile range. It's the 75th percentile minus the 25th percentile. Now, going by the definition in our book, the whiskers extend to capture all the data that's within 1.5 times the interquartile range of the box. Remember, it's not 1.5 times the IQR, it's all the data that's within 1.5 times the IQR. Any points you see beyond the whiskers are suspected of being outliers. Whether they are outliers or not depends on what you're doing, because there isn't a definition of outliers that fits every problem. But a box plot gives you a way to easily spot them. The number 1.5 is what our textbook has, and that's the way R does it by default. But you can actually control the length of the whiskers if you want using the range argument. I'll copy this and paste it. And I'll add an argument range equals 1. Now the whiskers will only extend to the data that's within 1 IQR of the box. I hit Control Enter, and that didn't do anything. It must be that none of the data is beyond 1 IQR. Let's try range equals 0.5. And there you see the whiskers got shorter. And now there's data that extends outside of the whiskers. So you can control the length of the whiskers if you want, but we won't be using this in this class. I just wanted to show you that there are other options for these things. Let's go back to the default, which is 1.5. If we wanted to know these percentiles, we could look at a table. We don't really need a plot like this to tell us that the median weight for the chickens is a little more than 250 grams. Box plots are most useful for comparing several different groups. I can make a box plot of chickens according to what food they got by using a squiggle. I type box plot chick what's dollar weight. Now squiggle chick what's, and I want to graph the weight by their feed. Control Enter. Let me zoom in so we can see the labels. A plot like this allows us to compare multiple distributions to one another. We can see that Cosane has a higher median than all the others. Sunflowers is pretty high too. Sunflower has a tight little IQR, but 2 high outliers and this low one. So it looks like with this one, most of the values were pretty close together, except for these 3 extreme points. And we can see that these 3 feeds, linseed, meat meal, and soybean, all have roughly the same size IQR. Meat meal seems to be right skewed because the distance from the median to the 75th percentile is much greater than the distance from the 25th percentile to the median. So 25% of the data goes from here to here, maybe 250 to 270. Then the next 25% of the data goes from about 270 to 320, or thereabouts. But I wouldn't diagnose skew from a box plot alone because there might be something else going on, like multimodality. And that's really what we do with box plots. They give us the means to quickly compare different groups. We compare their centers using the medians and their spreads using the IQRs and the whiskers. We can improve the look of the plot by using the same arguments we've been using. Let's give it a title. That would be main equals chick weights by feed, comma, label the axes. So X lab equals feed, Y lab equals weight in grams. If I say that col equals a single color, like red, all the boxes will be the same color. But since there are 6 boxes, I could give it a vector of 6 colors using the C command. So I'll change this red to a C. Type in yellow. Control Enter. And finally, if you prefer a horizontal box plot, there's an argument called horizontal, which is set to false by default. But if we enter horizontal equals true, we get a horizontal plot. 2 last things I want to draw your attention to. One, notice that true is not in quotation marks. True and false are parameters in R. They're treated differently than normal words. That's why they turn blue. 2, beware of formatted quotation marks. If you write your code in a word processing program or copy it from the internet, you might get formatted quotation marks that R doesn't recognize. Like, here's the word yellow in the formatted marks. Notice it's not green like it should be. If I paste this into my code, replace this yellow, and run it, I get an error because R doesn't recognize those marks. I have to retype them, which is annoying, like that, and then it will run. It's just a frustrating source of error to be aware of.